Okay, in this video, we're going to be looking at section 2.7 on solving inequalities. And my directions here are to solve and graph and write your answer as an inequality and in interval notation. So problem number one, I have the inequality x plus 2 is less than -4. And we're going to solve this problem just like we would do an equation. We're going to use inverse operations. So in problem one, I'm solving for x. I need to get rid of plus 2. So I need to do the inverse of adding 2, which is subtracting 2. So I subtract 2 from each side of the inequality. And I end up with x is less than -6. So I've solved it. I've got my inequality, and I need to graph this. X is less than -6, which means I want to look at all of the numbers to the left of -6. Those are all of the numbers that are less than -6. So the only question is, what symbol goes here at the -6? Is it a parenthesis or is it a bracket? And in this case, it's going to be a parenthesis because I cannot actually equal -6. There's no equal to sign under that inequality. So when I write my interval notation, I'm looking at my graph from left to right. As far left as I go is -infinity, and as far right as I go is -6. And remember that I need a parenthesis here at the end of my interval notation by this -6 because there's a parenthesis on the graph. Okay, problem number 2. I have 2 times x is greater than or equal to -10. I'm going to divide both sides of my inequality by 2. So I get x is greater than or equal to -5. So greater than -5 means I want numbers that are bigger than -5, so I want to shade it to the right of -5. And I need a bracket at -5 because this is saying I can equal -5. So from my graph, I get my interval notation. So again, I'm going from left to right. So I've got a bracket here at -5, and then as far right as I'm going is positive infinity. And remember, the positive infinity and negative infinity always has a parenthesis associated with it when we write it in interval notation. Okay, problem 3, I'm going to divide both sides of my inequality here by -5. And when I do, I'm going to reverse the inequality. Okay? So when I divide both sides by a negative or multiply both sides by a negative, you reverse the inequality. Now, if you go back up here to problem 2, you notice I have a negative here in the problem, but I'm dividing both sides of my inequality by a positive 2. Problem 3, I'm dividing by a negative. So my graph is going to be looking at all of the numbers that are bigger than -4, so all of the numbers that are to the right of -4. And in this case, I want x to be strictly greater than -4. So I can't equal -4, so there's going to be a parenthesis there. In my interval notation, I'm going to have parentheses, -4, and then go to positive infinity and a parenthesis there as well. Okay, problem 4. You notice I have a 2-step problem. I'm going to solve this like I would an equation. I'm going to get rid of this -1 first by using inverse operations. So add 1 to both sides of the inequality. So I have 2x is greater than or equal to -8. And then divide both sides of my equation by 2. So I have x is greater than or equal to -4. So when I'm graphing this, I'm looking at all of the numbers that are greater than -4, so everything that's to the right of -4. And I'm looking at putting a bracket here at -4 because I can equal that. In my interval notation, it's going to have a bracket, -4, and then infinity, and again a parentheses with the infinity sign. On problem 5, I have a variable and a constant on each side of my inequality. I'm going to get rid of the smallest variable term first, which is the 6x. So I subtract 6x from both sides. So I have 2x minus 4 is less than -10. Then I add 4 to both sides. Now we're solving this just like it was an equation. And I have -6 on the right-hand side, then divide both sides of my inequality by 2. So I have x is less than -3. So I'm looking at numbers that are less than -3, which means they're smaller than -3. So I'm shading to the left of -3. And I'm going to have a parentheses there at -3. Now when I write my interval notation, remember I'm using my graph to help me, and I'm going from left to right. So as far left as I go is -infinity. So that's the first part of my interval notation. And then -3 is as far right as I go, and there's a parentheses at -3. Okay, problem 6 is a little bit different because we have a compound inequality, which means we have 3 parts to our inequality. I'm still going to solve this problem the same way by using inverse operations. And the first thing I'm going to do is to subtract 3. And I'm going to subtract it from all 3 parts of my inequality. So on the left-hand side, I get -8. And then on the right-hand side, I have 6. So when I divide everything by 2, I end up with -4 is less than x, which is less than or equal to 3. So I have my x values sandwiched in between -4 and +3. So it's this part of the graph right here. And on the left side, I'm going to have a parentheses at -4. And on the right side, I'm going to have a bracket at +3. And my interval notation is going to have those same symbols, parentheses with -4 and a bracket with +3. Okay, so now it's your turn to try to solve some of these on your own. So pause the video, try and do problem 7, and then come back and check your answer. And there's your answer for problem 7. Okay, problem 8. I have a variable and constant on each side of my inequality. I'm going to get rid of my smallest variable term first. So I'm going to subtract 4x from both sides. So I have 2x plus 4 on the left-hand side of my inequality and -8 on the right-hand side. Then I'm going to subtract 4 from both sides and then divide by 2. So x is greater than -6. Numbers that are greater than -6 are to the right of -6. So I'm going to shade over here and draw my arrow to show that it goes on forever toward the right. And I need a parentheses at -6. So when I write interval notation, I use the same notation that's on the graph. I use a parentheses at -6, and then my infinity sign always going to have a parentheses associated with it. Okay, problem number 9, I'm going to subtract 1 from all 3 parts of my inequality. So I have -2 is less than 2x, which is less than or equal to 4. Now I'm going to divide every part of my compound inequality by 2. So I have -1 is less than x, which is less than or equal to 2. So I want numbers between -1 and 2, so it's this part of my graph right here. And I'm going to have a parentheses at -1 because there's no little line under that inequality sign. And I'm going to have a bracket at +2 because there is an equal sign under that inequality. And my interval notation is going to use the same symbols that are in my graph, a parentheses at -1 and a bracket at +2. Okay, problem 10, I'm going to subtract 2 from both sides of my inequality. So I have -4x is less than 8. Now I'm going to divide both sides of my inequality by -4. And remember that when I divide both sides by negative or multiply both sides by negative, the inequality sign reverses. So I have x is greater than -2, which means I'm going to be shading to the right of -2. And in this problem, I'm going to need a parentheses at -2 because I cannot equal -2. Get as close to it as I want to, but I just can't actually equal it. And my interval notation is going to have a parentheses at -2, and then we're going out toward positive infinity. Okay, problem 11, I have -3x plus 10 is greater than 4, so I'm going to subtract 10 from both sides of my inequality. So -3x is greater than -6. Divide both sides by -3, and remember when I divide by negative, the inequality reverses. So if x is less than 2, which means I want numbers to the left of 2, and here I've got a parentheses. So I have a parentheses, -infinity, +2 parentheses for my interval notation. Okay, problem 12 I would like for you to try to do on your own. So pause the video, do the problem, and then come back and check your answer. And there are your answers.